All right, so our next section that we're going to look at in our Hawks textbook is section 4.5, which is combining functions. So here we're going to look at operations with functions, so like addition, subtraction, multiplication, and division. And then we're also going to look at some composition of functions. So the first thing we're going to look at is going to be the addition or operations with functions. So we're going to look at addition, subtraction, multiplication, and division of functions. When you add two functions, if you see f plus g of x, it just means you add those two functions together. And sometimes it just means you write the two with a plus sign between them because they can't be combined at all. There's no like terms. Other times it means you can combine like terms. F minus g of x, again, subtracting the two functions. The one thing to pay attention to here is the function that you subtract. You always got to put parentheses around it so you can distribute that negative sign. F times g of x, we're multiplying the two together. And again, sometimes there's not much multiplying we can do. We can just write the two times each other. And then our last one is going to be the division of functions. The only caveat we have here is g of x cannot equal 0 because, as you know, in our denominator we cannot have a 0. And the domain of each of these new functions consists of the common elements or the intersection of elements that the domains of each had individually. So we have to say, we have to look at the domains of the original functions, and whatever they had in common, that would be the domain of the new function. Okay, so here, the first one we're going to do, it's going to seem a little odd to you in the beginning, but it's really not bad, I promise. They are telling us that f of -2, so the function evaluated at -2, whatever the problem was, we don't know, but that's okay, it equals 5. So when I evaluated the function at -2, we got a 5. When I evaluated g of -2, so a different function, and I plugged in the -2, I got a -3. So remember, think, -2, that's like your x value. This is like your y value. This is your x, and that is your y value. So the first thing they want us to do is find f minus g of -2. All I have to do here is I know that f of -2 is 5, so I'm going to do 5 minus my -3. So when I do that, 5 minus -3 is going to give me, think plus a positive, I'm going to get an 8. So f minus g of -2 is 8. Now, the next one, we wanted f divided by g of -2. So again, my y value is 5. I'm going to take my 5, or the answer, and then divided by -3. And that, honestly, because we can't simplify it, that's our answer for f divided by g of -2. We really can't do anything else with it. So that, nice and easy. We're going to work with some variables next, but that is what you would do with just numbers. Okay. Now we're going to work with more typical functions that you're used to seeing. And what they want us to do here is when we look at this, they give us two functions. We have f of x equals 4x squared minus 1, and g of x equals the square root of x. First, they want me to add the two functions together. So that means simply what I'm going to do for f plus g of x, it will be equal to 4x squared minus 1 plus the square root of x. And for this one, if you look at that, I don't really need the parentheses around the 4x squared minus 1. I put them in there, but we can remove them if we want. That's all we can do because I don't have any like terms, so I can't do any combining, so that would be my answer. Now for the next one, we are going to do multiply. So we're going to do f of g, or f times g of x, which means we're going to do 4x squared minus 1 times the square root of x. And we can multiply here. excuse me, I think the easiest thing to do would take this square root of x, instead of dealing at it as with it as a radical, I would change it into a fraction exponent. So I would really do this. I would do 4x squared minus 1 times x to the 1/2 power. And when we do this and we multiply, that's going to give us 4x squared times x to the 1/2 power is going to give me 4 times x to the, and again, remember when you're multiplying exponents, you add them together. So if I do 2 plus 1/2, 2 as a fraction, it's like 2 over 1, would be 4 over 2 plus 1/2. So it would give me 4 times x to the 5/2 power minus, and then 1 times x to the 1/2 would be x to the 1/2 power. And we could leave it right there. That would be it. They're not always going to be this difficult, but sometimes it is nice to see those fractions in there so that we can get used to them and practice with them. Now, what we do need to look at here is they're going to ask you about the domain for each. And with this one, for the first equation, your domain is all real numbers because there's no fraction and there's no radical to worry about. So I can plug in any number I want and get a y value. It doesn't matter. But remember, when you have a radical, like a square root or a fourth root, I cannot have a negative number under that radical. We're not dealing with complex numbers. So my domain for the first one is all reals, or negative infinity to positive infinity. But for this one, remember, x has to be greater than or equal to 0. And remember, when you find the domain for the two functions, if they ask for it, you have to put the intersection or what these two have in common. So in this case, I can't use, my domain can't be any negative numbers here. My domain, this would be the intersection, would have to be x is greater than or equal to 0. Or if I wrote it in interval notation, it would have to be 0 to positive infinity. So again, that's how you look at the domain with the. Okay, now for the next one, they want us to find f divided by g of 1. And you may be looking at this like, this is kind of crazy. Like they gave me a graph here. How do I do that? Remember, this value right here is like your x value. So what we have to do is we need to find f of 1. Or what is the y value? So if I go look, and they've labeled the equations, this one's f. If I find 1 on my x-axis, which is right here, and I go up to find the ordered pair there. All right, my y value, if x is 1, my y value is 1. Do the same thing with g. Find g of 1. And let's see here. If I, again, find 1 on the x-axis, which is right here, and you go up until you find the point where g is on 1. All right, my y value here is going to be 1, 2, 3. So 3. Now that we have the y values, just like we did before with the first slide and putting the numbers in, we do f divided by g. So it's going to be 1 divided by 3, or the answer is going to be 1/3. There's not much more that we can do here. And then let's see here. They do want us to find the domain. Now, we have two parabolas here. So, parabola, the domains for each, it's all real numbers. For f, it would be all real numbers for domain. Any x value would work. And for g, any x value would work. But because we do have a division problem here, so we're finding the domain for f divided by g. Remember, you can't have a 0 in your denominator. So we really have to look at the g graph to see where the parabola crosses over the x-axis. And it crosses over here at -2 and +2. So your domain can be any real number except x can't equal -2 or +2. Now, if you were going to write that in interval notation, it would be, so we could go from -infinity to -2. But we can't include -2. Put your union there. We can include anything from -2 to 2, but we can't include -2 or 2. And then it would go from 2 to +infinity. So it would be, anything along here, anything between these 2 points, and anything after them, but it can't include these 2 points because that's when g would be 0 and our fraction would be undefined then. Okay, the next thing we're going to look at would be composing functions, or the composition of two functions. And the symbol that they use, instead of like a plus, a minus, or multiplication or division sign, it is an open circle between the two functions. So sometimes people call it like fog or goff because, it looks like an O between them. It's not. It means the composition of functions. And it can be written with the circle, or they could just put like g of x within the parentheses for f of x. But what FOG stands for, or the fog, if you want to call it that, means f composed with g, or f of g. And I'll show you what that means in a second. And one thing to be cautious with when you're composing functions is the order does matter. So here, f is composed with g. That is first, and then g composed with f would be a totally different function. So if you start with the first function listed and plug the other function in. So it is something that order does matter with, and something to be pay attention to. Okay, so what we're going to start with here first is f composed with g of 6, or I'm going to do b first because I think it's a little bit easier to look at it that way first. So we have f composed with g of x, and because f is first, it means that I'm going to take my f function and put g in wherever there's a variable. So really, where x is, I'm going to plug in g. So f composed with g of x in this case would mean instead of x squared, I'm going to plug where the x is, I'm going to plug g in. It's going to be x minus 3. And then you do keep that exponent. So f composed with g means I'm going to take g and insert it into x for the other function, the first function, and then we're going to evaluate it. So what we're going to do is I'm going to do x minus 3 times x minus 3, because we can FOIL this. So it will give me x squared minus 3x minus 3x plus 9. So we get x squared minus 6x plus 9. And that's what f composed with g of x is equal to. Now, and I just think it's easier to do it this way. You can do it the other way. You can plug in, you can do f of 6 to figure out what this value is, and g of 6 to figure out this value, and then put them together. Or what I do is, now that I know f composed with g of x, I'm going to plug in my 6. So I'm going to do 6 squared minus 6 times 6 plus 9. So 6 squared is 36 minus 36 plus 9. So 36 minus 6, 36 is 0, plus 9 will give me a 9 for that one. I personally think it's easier to do it that way. You can, like I said before, plug in the 6 for both and then do the math. It's up to you. Okay, so we are going to look at now the composition of two more functions, and then we're going to look for the domains of each, which each one has kind of like a little bit different situation with it when we look at the domains. So it's good to look at the domains for both. All right, so the first one is f composed with g of x. So that means that we're going to take f of x, and wherever there is an x, we're going to plug in g. So that would be, instead of x squared, we would do the square root of x, and then you keep the exponent for the original value. So we have the square root of x squared minus 4. And when I go to simplify that, the square root of x squared always gives us x minus 4. So if I'm going to simplify or look at my domain here, if I look at the answer, in this case, it looks like, hey, I can do anything I want. But if you go back to the original functions, we do know that the square root of x, which we did plug in here, we cannot plug in a negative value for the square root of x. So that means even though the domain for this function and this one is all real numbers, because I do have that radical in the original part there when I'm going to plug in numbers, I cannot plug in negative numbers. So my domain here is going to be 0 to positive infinity. And again, sometimes you have to do a little investigating. We had to go back and look at the original functions because this one looks like all real numbers. Now the next one is going to be a little bit different domain-wise. We're going to do g composed with f of x. So let me erase this part a little bit. All right, so that means we are going to start with g and then plug x squared minus 4 in for x. So when I write it, it's going to end up being this, x squared minus 4 under the radical, and that would be g composed with f. I took the g function and I plugged x or f of x in where there was an x. Now, for this one, we have a radical here, and we know with radicals we can't have negatives. So that means whenever you find the domain of your radical, you're going to take, and I'm just going to take what's underneath that radical, the x squared minus 4. Remember, that always has to be greater than or equal to 0. So when I go to solve it, I'll add 4 to both sides. So I get x squared is greater than or equal to 4. And then, we're going to take the square root. We want x. So x always has to be greater than or equal to, and again, we're going to end up with our positive or our negative 2's there. Or, so really, our domain here, what we're going to get for our domain is it's going to end up like we were to graph it on a number line, and I know this doesn't quite look there. We have negative 2, we have positive 2. It can be any number greater than 2, or, because I should switch the sign with my negative 2, any number less than negative 2, because I did not switch it up correctly. I apologize. It really should have been, let me erase a little bit. When we took the square root here, I want you to think, write it, it would be x squared, the square root of x squared, and then we're going to put our 4 here, which gives us our 2, or x squared, we get our x. But when you do your negative 2, you have to switch your sign. Because remember, when you divide by a negative or you have that negative in there, that inequality sign switches. So your domain here is going to be negative infinity to negative 2, and it can include negative 2. And then it's going to be positive 2 to positive infinity. All right, hopefully I made that a little bit clearer. I know that wasn't perfect. I apologize. All right, and the last thing we're going to do here is we're going to decompose a function. Basically, we're going to take a function and write it in 2 separate functions that we could put together to get this function right here. So a composition of 2 functions. Really, with this one, there's multiple different answers you could use. You want to kind of just try to break up your equation and put it into something simpler. Sometimes, I look at, when I'm doing this, like, what did they do? Like, what are 2 simpler problems that I could use to get the equation? I look for maybe like a parent function. So here, what I could do is, if I want to break it up into two functions, I'm going to take a look at this equation. We have the absolute value of x squared minus 3 plus 2. So, we're going to need like an x or something. What I would do is this problem right here within the absolute value, my first function that I'm going to make, like I'm going to say f of x, doesn't really matter what you call it, but I'm going to make that my x, so the absolute value of x, and then keep the plus 2. And then because then, if you do a composition, I'm going to make g of x like you would plug in. So I'm going to make it x squared minus 3. So that means what I would do is I did f composed with g. I would take this equation here and plug it in the absolute value. And that's kind of what you want to do, is look at, what is in, if you have parentheses, what's in those parentheses that you can take out and call x, and that will become like your second function. Again, there's lots of different ways you can do it. As you do the homework and you mess with it, you'll kind of see like different ways that you can look at them, different ones you can look at. Let me give you guys one more to try. Let's look at f of x. So the original function is f of x equals the cubed root of 3x squared minus 1. And I want it into two different functions, a composition of 2. So again, we have the cubed root of 3x squared minus 1. Make it easy on yourself. And I'm going to use like two different numbers, but g of x. Make it the cubed root of x. So get rid of what's under that radical. And then, we'll call it h of x. Doesn't really matter what we call it. But now do your 3x squared minus 1. So kind of think of like, what was the parent function? What was the function, or what's under the radical? So if I do g composed with h, that means what I would do is take this and plug it in to there. Maybe we'll do one more. We'll do this time f of x equals 2 over 5x minus 1. This one here, you got like a fraction. What I would do, again, focus on that denominator. Make that your x. So you got to figure out what you're going to make your x. So we'll do g equals 2 over x. Whatever I removed and made x, that's going to be your second function. So my second function will be h of x equals 5x minus 1. Again, there are different ways to do it. Yours may not look exactly the same as mine, but you'll still, if you can do the composition of the two and it works, then you're good to go. Hopefully these notes have been helpful, and I will talk to you guys later. Bye.